Okay, it's 1 o'clock, so let's get started. I want to start with group coding today again, and this time I want to try Will's idea. Will's not here, I guess. Will had the idea of having like the coding stick in the group coding. So we're all on the same portal, but only write code if you have the coding stick, right? I think paper airplane is more fun though. So we've got a paper airplane, and what I want to do is I just want to go over the homework on the board, but I want you guys to take turns kind of putting up line by line what you had. So let's do it. You want to throw it? You want to start, or do you want to throw it?
I'm not starting.
Okay. If you didn't do the homework, that's okay. So you can just throw the paper airplane again. If anybody wants to do something, you raise your hand and we'll throw the paper airplane over to you.
You already have this. Wait, what am I supposed to do?
Well, so, okay, everybody joined this portal. I sent out the portal link. That's step one.
Just throw some code out there.
And then step 2, we throw airplanes at you?
No, at each other. At each other. Yeah.
Okay.
It's the coding stick. I'm taking your coding stick idea.
Okay.
The paper airplane is the coding stick.
Nice.
Yeah.
That seems like that's controllable trajectories.
It doesn't. That's the idea. It's unpredictable. You never know who's going to write the next line.
It'll work. Trust me.
No plus plus in Python. Only plus equals 1. Yep.
So you just want like one line, or do you actually want like...
Just whatever you feel like writing. I would say no more than one line because we want to take turns.
Just writing like literally anything?
No. We're going over the homework. So, and I want to take turns having people write, start something. Okay. All right. So we've got it started. Anybody want to go next, or are we just throwing the paper airplane?
Do it again.
All right. Looks like we're just throwing the paper airplane.
All right.
Almost. All right, how about this? If you're throwing the paper airplane to a specific person, every person it lands to while en route to that person can take a turn if they want. Okay, so you could take a turn now if you want, but if not, that's okay. Def new func. Okay. And you're taking in star args 2 and star quargs 2. Okay. Interesting. Anyone want to go next?
Who wants to? Alright, you're getting it.
Hey, direct hit.
I don't know what's the next session.
Just write another comment next to mine.
Yeah, you can you can pass by putting a comment.
Or you can
Oh.
type pass.
Passive aggressively correct my comment.
Okay, that works. Okay. Anyone want to go next? Will wants to go next. All right.
Sorry.
Oh, so now you can take a turn if you want.
Or not.
Or not. Okay. Yeah. Maybe. Hey, can you pass the paper airplane? To Will. Okay.
So this is just based on how I made it work in mine. But I imported the arguments and keywords from the main function first. I don't know that it's necessary, but it got kind of broken when I didn't do that.
Okay.
Change it to.
And then that let me use those in the new function. But I guess if we've done args and parts too, then that's not necessary.
Exactly. Yeah. But that works. That works.
Then instead, can I define a list of the new arguments?
That's not.
No.
Does anybody want to explain to the rest of the class why the outer function takes in star args and star quargs?
Yeah, please.
So that you can have as many positional arguments and keyword arguments as the function requires.
Yep. Yeah, so the idea with partial is that we're binding args and quargs to func. So we're setting up func to be called on the following arguments. And so we want to be able to take in any number of those following arguments. Yeah.
So that's how I set it up to deal with the all of the arguments together, combining them. Which,
Okay.
oh, plus this one.
Alternatively, we can do
All right. Who wants to go next?
If anyone wants to make this cleaner, let me know. I was on this note somewhere.
Over here?
Oh, God.
Ooh.
Oh,
I think I'm not going to do that.
All right.
Oh,
So what I'm learning is maybe not use a paper airplane. Why don't you just go ahead and write? Well, let's ditch the paper
I mean, I was
airplane.
going to write that return statement.
Okay. So yeah, explain what's going on here. What?
Rather than appending and passing one. But rather than appending them all together and then doing so, we can just expand them all together in one return statement, and it will all be taken care of.
Okay. So you're saying that we could merge args and args2 into one list, or we could just unpack args1 and args2 separately. Yeah, that also works. Yep. I'm not sure if it works for dictionaries, but did it work?
I
It did
thought
work?
it
If you do double, or if you do double star.
If you use double star. Okay.
I
So
thought
apparently
I
this.
tried it and it didn't work.
For some reason I thought it didn't work either. But it's we'll consider it an implementation. Okay. Well, regardless, the important thing is what goes on in here is we're taking args1 and args2 and we're passing them into func, both. We're passing both. And then we're taking quargs1 and quargs2, passing them both in. So that's the important thing. And then we're returning the result. Okay. So does anybody want to move on to the next line? Uh-huh.
What's the point of having more args if you're not even using it in the function?
Well, we didn't here, but when I did it, I did function of more args and more. I did another thing for more quarks. That was the dictionary. So this is kind of like patched it together.
Yeah.
If we get paper plane, can we add it on?
Yes. So the question was, why do we want args2 and quargs2? Is that the question?
It was you create this array more args, but you don't ever really use it.
Oh, yeah, that was just one way of doing it. This is another way of doing it. Yeah. Yeah. Okay. Do you have the paper airplane? If not, just go ahead and write it. Don't worry about it. We're ditching the paper airplane. That was too hectic. Next time we'll use a frisbee, maybe. Well, that might be dangerous.
What are those fabric
Fabric frisbees?
Yeah.
Basketball? All right, anonymous feedback, what you want to pass next time, okay? Are you writing the next line here?
Just wait a minute.
What did you do?
I changed args to star args plus args.
So that also works. Yeah, you can do either one. Yep. Okay, does anybody want to write the last line?
No, the last line.
It's a brave line. Yeah, go ahead. Oh, someone's writing it? Note. Oh, yeah. Adam does some weird autocomplete stuff.
Yeah.
Return new func. Interesting. Why don't we put parentheses here?
It's the whole function.
Yeah. We want to return the function itself, not the result of calling the function. Okay. I just wanted to go over the homework because I realized in office hours yesterday that this was probably harder than I intended it. But I wanted to both show you closures and star arg, star quarks. So here we had to use a lot of stars. And this is a closure because this new function refers to star args and star quarks even after the initial partial function goes out of scope. So this is a closure. Okay, someone is writing another. I don't know who's writing this. But yes, this is also a partial function. We don't need parentheses.
trying to get to as few lines as possible.
All right, if we want, all right, so everybody, stop writing and check this out. Here is the shortest solution. Are you ready? It's going to blow your mind. From Func Tools, import partial. So there was kind of a meta assignment here, and that was to see if you look up the API, because it's built in, so you can just import it. It turns out that this is such a common thing that you want to do, bind functions to arguments without calling the function, that it's built in, and then that's called the partial function. So just so you know, really useful. I use it not every day, but like a lot. I use it a lot. In fact, like, for example, all right, and the portals. Everybody comment your computing ID at the top. That's attendance.
This one.
Oh, man. Okay, all right. Stop. Everybody stop. What happened? Everybody on a new line. Adjust your computing ID. If you put something else, I'm going to mark you as absent. That says Shrek. If your computing ID is Shrek.
What if you have an alias?
No aliases.
3 times.
Shrek. Someone's had it done that already.
Okay, that looks good enough. Everybody put theirs down.
Mine's broken right now.
Okay, can somebody, what's your computing ID?
MG2NF.
Somebody put it, are you putting it down?
I'm doing it.
All right.
MG2NF.
Yeah.
Okay.
Wait, some of them just got released.
Yeah, a bunch just got deleted. Make sure yours is
Someone's
still.
trying to take my spot on the top line. No.
It is not a competition to have the top line. No extra credit will be given. Okay. 5, 4, 3, 2, 1.
Someone right.
Okay. That's who was here today. So.
Did someone start writing code PP?
Okay. I just want to show you an example of partial in some real code, because it turns out that I actually used it to write the secret tester for the prisoner's dilemma. So this was the code that I actually ran, not the code that was vulnerable. So I blocked cheaters, blocked crashers, etc. But I wrote this function safe action, which takes in a function, and the player who's trying to perform that action tries to call the function, and then if there's an exception, it counts it as an error and gives you a penalty. So basically, I wrote this because every single time I called anything on one of your prisoners, I wanted to make sure to catch any exception, because otherwise the runner would crash. So this just takes in any function, and then what I would do is I would call partial on your player and sentence. So yeah, like let's look at an example. Here I'm calling partial on instance1.sentence. This is a method. This is your sentence method, and I'm calling partial on it and s1, the sentence that you got. And then I'm passing that function into safe action, and that will ensure that there's no exceptions thrown, and that if there is an exception thrown, it'll count as a score penalty. Okay? So that's an example of partial. It's a really useful thing to know. And it's metaprogramming because it's a closure. I'll get more into that later. But let's get to the slides. The homework this week is really chill. I made the homework this week what it is because it's a pun. The homework is a decorating contest. Just write a creative decorator. So get it, decorating contest. Is that a pun? I don't know if that even counts as a pun, but it's a joke, right? It's a double meaning. So that's why there's not much value to this homework except that it's kind of a funny title, and you'll get some experience with decorators. So
The best type.
also, no class next week. I'll just go ahead and say that. Fall break, obviously, no class. So Okay, we're going to do decorators, but first I want to go over closures just really fast, even though we just did the example, because it turns out decorators are basically just closures. So we've got a function called makeClosure, and we've got some local variables in makeClosure, whether they're arguments or just local variables that we created. We make an inner function, which makes an inner scope, which refers to those local variables, closing them. And then if we return the closure, these variables are kept in memory even though the outer function has terminated. So that's just a reminder of what closures are. So decorators are a subset of closures. Oh, okay. I was trying to frantically fix all the animations this morning. I guess I missed one. I don't know why that's there. Okay, so now we're calling this function decorator, and you'll note that it takes in a function. Okay, so that's property one of decorators, at least for now, is that they take in a function. Okay? And then we call our inner function wrapper. You don't have to call it wrapper, but I'm calling it a wrapper because that's what it is. And this wrapper needs to match the function signature of func, because it's wrapping. This wrapper wraps func. So the wrapper should have the same signature, and we're guaranteed that wrapper will have the same signature as func if we take in star args and star quarks. So there we go. Finally came back. Okay, the wrapper should return the result of calling the original function with those arguments. So this is just a wrapper. I mean, this is even simpler than partial. This is just a function that calls func. It's a wrapper function for func. Takes in any number of arguments and then passes those arguments right into func. And then we return the wrapper. So this is the special form of closures that constitute decorators. So let's see it in action. Here's a decorator, the debug decorator. I have written this decorator probably 20 times. Not 20 times, but it comes in handy. It's handy. There we go. So first thing we're going to do is we're going to print that we're decorating this function. Just that way we can keep track of what's actually going on. So this is we're going to print that we're decorating this function, and then we're going to define our wrapper. And our wrapper is going to take in star args, star quarks. We're going to print the function name and the arguments that it's being called on. And this way, our debug decorator will allow us to just keep track of what functions are being called when. And that's really useful when you're debugging. And then we're going to return the result of calling the func on those arguments. Just a wrapper function, but we added a print statement. And then we return the wrapper. And now for demonstration purposes, let's say we have this function foo, and it does nothing. And if we call the function, nothing happens. Okay? Got debug decorator. We've got a wrapper. It prints the function that's being wrapped and the arguments that's being called on. So take this line right here. Foo equals debug foo. What is that doing? Well, we're treating foo as a first-class function again. So we're back to first-class functions. Foo is a variable, which refers to this function, pass. We're passing foo into debug, which means that we're wrapping foo. So foo gets wrapped. This wrapper here is going to call foo, because func is foo. And then we're assigning that wrapper back to foo. So as soon as we say that, we get a decorating foo, right? Because we call debug, and the first line of debug is print. So we print decorating foo. And now if we call foo 1, 2, 3, what do we expect?
Foo being called on.
Yeah, foo being called on 1, 2, 3. So we've achieved what we wanted here. Our debug decorator is now making it so that this function tells us when it's being called and what it's being called on. Print equals debug print. What do we expect here? decorating print. And then if we print 1, 2, 3, what do we expect? So here's the thing. You have to be careful with decorators, because sometimes you can get really weird behavior. This would be a recursion error, because our decorator calls print. So just be careful. If your decorator calls the function that you're decorating other than right here, you could get into really weird scenarios. So just be aware of that. Does this make sense to everybody? This is basically a function that wraps things. We've got functions. We've got functions that wrap functions. And then we've got decorators, which make wrappers of functions. So decorators are like wrapper generators. Okay? Now, Python provides us a little bit of syntactic sugar here. This line, foo equals decorator foo, it's a little weird. You'd have to know about first-class functions to ever even think to write this. So Python gives us an alternative. Instead, we can use @debug. So we named the function, or let's see, what our decorator was named debug. Okay. So what we can do is basically just say and then the name of our decorator. So @debug, and then we define our function. Def bar a print a decorating bar. So what happened here? We said @debug, and then we defined this function. And before we even got to the next shell prompt, we got decorating bar. So what this syntax does is it says, as soon as you say @debug, Python knows that whatever comes next, go ahead and pass it into our decorator, and then reassign it to the original variable name. Huh?
So if, say under the def bar stuff, you then did, you defined like another function, would that be decorated also, or do you need to do the every time?
You need to do the for every definition. Yeah. So every function you want to decorate, you need to use the Yeah.
That like @debug, is that like you declare that and then the next line is your function?
Yep.
Okay.
Yep. You use @debug, and then the next line, the next keyword you use should be def. Yeah. Mm-hmm.
This is a continuation from what was on the previous slide, where it was the debug function.
Yeah, this is the same scenario. Yeah. Uh-huh.
What if you want 2 wrappers, like 2 decorators?
Great question. If you want to, you just list them out. You can say @debug, @log, and then next on the next line. Any more questions about this? And then we get what we expect. Now when we call bar, we get our debug information. How nice. So now what if we want to have like a parameterized decorator? Okay, so here's my example. We've got @debug prefix, and then we pass in a prefix here. And the idea is that how many times have you been, printing out debug information, and you leave it all in there, you don't remove your old debug statements. I mean, who does that? And so eventually you find a bug, and you realize that you need to debug it, and you add a new print statement, and you realize that it's impossible to find that print statement in your debug output. So you just tack on *** to the beginning so that you can search for *** and find that line that you just added. Right? Who's done that? I've definitely done that. Oh, okay. Maybe that's just a me problem. But I never remove debug statements, and so I end up having to do this. And the idea is that then you can search for ***. So what if we want to do this? How do we do it? See, now when we get our debug information, we get a ***. Now, this is kind of a lame example because *** isn't very informative. But what if you want to organize your debug messages into, syntax debugging and mathematical debugging and database debugging? Then you could use your prefix to be able to sort by all that stuff. So it's useful to be able to do. Any ideas on how we would do this?
No.
No?
Wrap the debug function?
Wrap the debug function.
Maybe?
Yeah, that's actually really close. This is really counterintuitive to me, but the way you do this is you write your decorator, debug prefix, and it takes in the prefix, not the function. Okay? So whatever parameters we want to take in, you take them in here, but you don't take in func. I mean, you'll recall on our old decorator, on debug, we took in func. So what I'm saying is here now, if we want to take in parameters, then you don't take in func, you take in your parameters. Then you define an inner function that takes in func. Then you define the wrapper. Then you do your wrapping, you return the wrapper, and then you return the in-between. This doesn't really make sense to me, but it does if you think about it, because here, okay. So when we didn't take in arguments, we just said at debug. We didn't put parentheses here, right? You did not need to put parentheses here. You just say at debug. But here, we're putting parentheses, which means we're calling something. Well, what are we calling? We're calling this outer function. You're calling this outer function, and the outer function makes you your decorator. So that's how I like to think about it. Or another way you can think about it is the function call is evaluated first. So we've got this function called debug prefix on prefix. That is evaluated, and the result of that evaluation should be the decorator. Does that make sense? Uh-huh.
You're going to do this like without the at notation, like the way you did it the first time you showed us on screen. Would it be weird?
That's a great question. Here's what it would look like. You would call debug.
Would you have like multiple sets of parentheses next to each other?
Yeah, you would have debug decorator on your prefix, and then you would call the result of that on food, and then set that equal to food. Yeah. Any more questions on this? It's a useful thing to be able to do. There's another way of taking in arguments if you use a class. I don't totally... this is my favorite way. So if this just doesn't make sense to you, then there's another way to do it, and I'll let you look that up. Okay. So here's another thing you can do with decorators. You can decorate classes. Okay? And the thought behind this... Or here, I'll just show you the example first. We've got at debug class, and then we have a class definition instead of a function definition. Okay? And let's just say what we want to do here is we want our class decorator to just in turn decorate every function. So, this debug class decorator should decorate every function in the class with the same debug behavior that we had before. So now, when we call b.foo, we've got b being called on instance of bar 1, 2. And notice this is static here. This is static debug information because we've got self. This is self. Okay? Does that make sense? Does everybody understand what we're going here? We're doing a decorator for a class, and that class decorator should in turn decorate every function. So, we're going to write a function, but it's going to take in a class instead of a func. Kind of makes sense. And then the idea is that basically, instead of writing a wrapper function, we write a wrapper class. So here's our wrapper class. Class, wrapper, star class dunder basis. The idea here is that we want our wrapper class to inherit the same things that our class up here did. So we have to get the base classes of the class we're wrapping and unpack them into this class definition. It's a little weird syntax, but this works. You unpack the base tuple, the base class tuple, when you're wrapping the class. Okay, and then for now I'm just going to do pass. So what we've written here is a wrapper class that inherits all of the same things but has no content. And that's because what I'm going to do now is loop through all the functions in the class that we're wrapping, decorate them, and add them to the wrapper class. So we've written kind of a temporary wrapper class, just an empty shell of a class. And then this says basically for every function in that class, we set the attribute on wrapper of that key to the debug of that value. So this is actually getting into reflection a little bit. So I don't expect you to completely understand this right now because the inspect module we haven't gone over yet, and that's reflection. But you can think of this as basically looping through everything in the class and applying the decorator and then setting that attribute in the class to that new thing. Is there a question over here?
Yeah, I was going to just ask, does that mean inspect is fair game now?
No. So, yeah.
So you're looping through the methods in class, not the wrapper.
That's right, yeah. Well, the wrapper at this point doesn't have any methods. So we loop through all the methods that we want to put into wrapper, and we set them to wrapper. Yeah.
Now you could also, if you wanted your wrapper to actually do something different, instead of passing, you would then set like additional attributes.
Yeah. So like, let's say there's actually I had to do this looping here because I wanted to apply the debug decorator to every function. But there's a simpler way to do this. You could just set, I don't know if you guys remember, but way back on day 1, very first lecture, I showed you dunder dict.
Yeah.
And it gave you everything, all of the available methods that you could call. I think I gave you the example of a list. We said like list.dunderdict, and we got a dictionary of everything that you can call on lists. Well, you could do the same thing here. And what you could actually say is right here, instead of looping, you could say wrapper.dunderdict equals class.dunderdict. And that would just copy everything over. Pretty sure that would work.
You would do that within the class? Or
You would do it right here.
Okay.
You wouldn't do it inside the class. Yeah.
Okay. So you always have to do that pass structure there?
Well, so you wouldn't have to necessarily say pass here, because what if you wanted your decorator to add some method? Like maybe this is a decorator, a class decorator, let's say runnable. Let's say this is a runnable decorator, and anything that's decorated by the runnable decorator has a method called run. Then you would put that run method right here. And basically, we would wrap the class and insert a run method here. So it doesn't have to say pass, but I'm just saying pass here because I want an empty shell of a class that we can populate.
What if you needed your method that you were adding to the wrapper class to use stuff that was in the earlier class? So like you needed to populate it before you wrote the new method. How would you do that? I don't know if that's even.
So because of the way because of the way Python is evaluated, it wouldn't matter.
Okay.
So like let's say you want to insert a method here that depends on the method that we know already exists in class, but we haven't added it yet. That's actually not a problem because Python, that would give a name error, except that it gives a name error when you call the method. And so by that time, we will have populated the rest of the methods.
So long as you don't call it before you populate it.
Yeah, exactly. You can call it in the method, but as long as you don't call the method. You see what I'm saying?
Yeah.
Yeah. Okay. Return wrap. So this is metaprogramming. This is definitely for sure metaprogramming. We've kind of been ramping up slowly. Closures is kind of arguably metaprogramming, arguably functional, but decorators are meta. Why are they meta? Well, because we're writing functions that take in a function. What's the definition of metaprogramming? Code that manipulates code. So when we write a decorator, what we're really doing is writing code that takes in code, changes it in some way, and then returns it. That's meta. That's metaprogramming. So this is our first real metaprogramming topic. This also ties into aspect-oriented programming. Who's heard of aspect-oriented programming? So it's not what you might think. Usually when people hear aspect-oriented programming, they think, oh, it's an alternative to object-oriented programming. That's not true. It's usually a supplement to object-oriented programming. Aspect-oriented programming is the idea that usually you can divide your code base into aspects. So let's say this is Facebook or something. Or, no, that's not a good example. YouTube. YouTube has payments, messaging, and content all in one. And so they probably divide their code base into aspects. There's the repo, which deals with payments. And there's, the folder that deals with messages and the folder that deals with content. These are each aspects. And they're mostly independent. What so-and-so says to so-and-so should not affect your payments, and so on. The problem is that there are some things which are relevant across all the aspects, and these are called cross-cutting concerns. So debugging and logging, these are cross-cutting concerns because all aspects need debugging. All aspects need logging, no matter what they actually do. And so in aspect-oriented programming, basically, you're very explicit about this structure. And you write functions that are cross-cutting concerns, and you write functions that are aspects. And in this scenario, debugging and logging, decorators, are cross-cutting concerns. So we would use decorators to fix cross-cutting concerns. The idea is that basically, when you want to debug a function, you should not add the debugging code straight to the function, because then you've introduced something that the function should not do. Let's say we have a function, validate payments. This function obviously should validate the payments, and it's very important that it does that. Let's say it's not working, and we add a print statement right here, print, args. Now this function does two things. Now this function validates payments and debugs itself. That's bad. That's unorganized. And so it's much better, and it would be very aspect-oriented to instead decorate this function, debug. And the idea is that way we separate our concerns. This notion is called separation of concerns. You want to separate your debugging from your business logic. And it's very clean. And, I bet if you mention it in an interview, they'll be like, ooh. And that's it. That's all I got. Short lecture, because decorators are basically closures, and so really just going over a quick subset. That's all I had today. So class dismissed. Have a good week. Have a good fall break.
So is the homework due?
Ooh, good question.
2 weeks?
Yeah, homework. We'll say the homework's due in 2 weeks. Homework's due in 2 weeks.